Hey builders, my name is Jaswanti. I am a product manager with the CloudFormation team.
And my name is Adam Ruka. I'm an engineer on the Cloud Development Kit team.
So Adam and I are really excited to share some of the latest features and products that CDK and CloudFormation have launched this year. So that's what the session is going to be all about. I do want to start the session by telling you that there's a lot of information that's packed in here in about 60 minutes. So you're going to feel like you're going to drink from a fire hose, but I promise you we're going to try and explain each of these features with an example, so you'll be able to follow along. I'll start. The agenda is fivefold. First, I'm going to start off by addressing one of the most top frequently asked questions. When should I use CDK, and in what aspects would CloudFormation be better? Then I'll give you an idea of what CloudFormation and CDK have done in terms of coverage, as well as some of our major launches for this year. And obviously, I know that you really want to save time, so I'm going to talk to you about some ways in which you can use reusable infrastructure patterns. And I know compliance is on everyone's minds these days, so I'm going to give you a few tips where you can step up your compliance game. And then I'm sure everybody wants to speed up your deployments, right? Like, time equals money, so I'm going to give you a few tips there as well for both CDK and CloudFormation. Finally, I'll just close out the session with some call to action items that you can all take away. Cool? Okay, so as a product manager for CloudFormation, I get asked day in, day out, what is when should I use CloudFormation, and what ways would CDK be better, right? Like, this is one of customers' top asked questions. Well, the TLDR version of this is AWS does not prescribe one over the other, and it's really up to you to choose. First, let me give you an overview of both of these products. Then I'll give you my take on the selection criteria. Okay? So CloudFormation is a managed AWS service which uses a declarative domain-specific language which you can write in either JSON or YAML formats. Because it's a managed service, a lot of the onus of the actual provisioning is taken over by CloudFormation. So for example, we want to make sure that we always leave your resources in a stable state. CDK is an open source client-side framework in which you write imperative code in a programming language that you are very familiar with. Right? It could be Python, JavaScript, TypeScript, as well as Go. Now, the last one, Go, is one of the most recent launches. Adam is going to talk about this in a bit more detail. And then in terms of my selection criteria, I think of CDK as an abstraction layer built on top of CloudFormation. Now, why do I say that? Because as you may or may not know, CDK is actually built on top of CloudFormation. Anything you write in CDK pretty much gets converted into a CloudFormation template, which is then used to provision your resources. So, I believe these two tools are very complementary. And as builders, it's really up to you to pick and choose which one would work best for you, as well as your organization's specific development practices. Just a high-level overview would be, if you're really looking to gain very granular control of your resources, then perhaps directly manipulating the CloudFormation templates would be best suited to your needs. Whereas if you're looking to just use a programming language that you're very familiar with, absolutely go for CDK. It might be right up your alley, right? With that message, I'm going to let Adam kick us off with some of this year's major improvements to both products, as well as the coverage updates I'm sure you're all waiting for.
Thanks, Jazz. That was a great introduction to both CloudFormation and CDK. And the first area we want to cover today are the major launches from both products, which are features developed based on feedback from all of you, the AWS customers using these products. And we decided to emphasize coverage among them, especially as we hear from many of you that you can't use a new AWS service or a new feature of an existing service in your applications running on AWS if that service or feature can't be provisioned using infrastructure as code. And that makes service coverage an especially crucial aspect of our IAC tools. Undoubtedly, the biggest CDK launch of 2021 is graduating CDK v2 to be generally available. This is a culmination of a multi-month effort by the CDK team and a long period of v2 being in developer preview. So thank you everyone who tried v2 before it was stable. Your feedback was absolutely crucial in getting this product over the finish line. The biggest difference between v1 and v2 is that v2 greatly simplifies module packaging. If you've ever used v1, you know that the product is composed of over 200 separate modules, roughly one for each supported AWS service. CDK v2 merges all of those separate modules into one, called AWS CDK lib, although note that the exact name depends on the programming language you're using with the CDK. This means when comparing v1 to v2, you will have to change the dependency declarations in the build tool you are using, and it also has the consequence of requiring changes to the import statements inside your CDK code. Exactly how much needs to change depends on the programming language you're using. Some of them, like JavaScript or TypeScript that we see on the slide, use the name of the module directly in their import statements, which means they will need more changes, while others, like Java or Python, have the concept of a package or a namespace, which means they will require less changes. However, besides these hopefully straightforward and mechanical changes to dependency declarations and imports, there are no other significant differences between v1 and v2. All of the tools, concepts, and code that you're familiar with from v1 works exactly the same in v2. And that means the migration from v1 to v2 should be a straightforward process without requiring any interruption to your existing CDK applications. Now, the move from multiple separate modules, what we call hypermodularity, to a single module, which we refer to as monolithic packaging, is a pretty radical change. So I want to explain in detail why did we decide to go that route and what benefits does it bring. First, it simplifies the management of dependencies. Instead of having to edit the dependency declaration each time you wanted to use a new AWS service in your CDK app, now all services are available for a single module, no edits required. Additionally, because of the complicated interdependencies between the CDK v1 modules, all of them need to be in the same version in a given CDK app. However, what would sometimes happen is that when adding a new dependency or when upgrading your CDK version, an inconsistency between the versions of the v1 modules would be introduced accidentally. And the result of that would be a pretty cryptic error at runtime. This problem has been completely eliminated in v2 since there's a single module now. It's not possible to have any version inconsistencies. The second advantage of monolithic packaging is that some package managers prefer downloading a single larger file to many smaller files. So for example, for Python, we've actually seen an improvement in the total time needed to download CDK dependencies in v2 compared to v1. The third advantage of monolithic packaging is that it makes third-party construct libraries easier to both offer and consume. In v1, because of the requirement mentioned before that all CDK modules must share the same version, using a third-party construct library in your CDK app would effectively pin your CDK version to whatever version that third-party library depended on. And you couldn't upgrade until first the construct library offer bumped the version of CDK they were using in their library, then second released a new version of their third-party construct library, and finally you bumped the version of your dependency on that. And needless to say, that's a very long and complicated process that involves multiple parties. And additionally, it meant that it was virtually impossible to use multiple third-party construct libraries in the same CDK app. Now, CDK v2 solves all of these problems. So third-party construct library offers can now declare a pure dependency on AWS CDK lib, and they specify the minimum version that they need for their library to function. And the final decision on what version of CDK to use is with the offer of the CDK application, where it should be. And this is absolutely critical in fostering a healthy ecosystem of third-party packages around CDK, and we'll talk about that ecosystem more when we get to the Construct Hub part a little later in the talk. And finally, the last advantage of monolithic packaging is that it clearly distinguishes between stable and experimental modules. If you've used the CDK before, you probably know that different CDK modules have different stability guarantees. Most of them are stable, but several are either experimental or developer preview, which means they can have breaking changes made to their APIs in the future. Unfortunately, because of the requirement that I mentioned before that all CDK v1 modules have to share the same version, the non-stable modules had to have the same version as the stable modules, which breaks semantic versioning and means that some customers actually relied on non-stable modules accidentally without realizing that they did not guarantee backwards compatibility. In V2, this is no longer the case. All code that is shipped as part of the monolithic AWS CDK lib is stable and guarantees backwards compatibility for the entire lifetime of the V2 major version in accordance with semantic versioning, and all experimental and developer preview modules are released separately from AWS CDK lib, and both their name and their version contain the word alpha, which means it will be no longer possible to confuse them for stable modules. So those are all of the reasons CDK in the V2 has moved to monolithic packaging. Now, I want to discuss the improvements in coverage of the higher level constructs in the CDK. What we usually refer to as layer 2 constructs, is those are the most commonly used constructs by CDK customers. In 2021, we released 20 new construct libraries for AWS services that didn't have any layer 2 coverage before. Additionally, we graduated 25 construct libraries from either experimental or developer preview to stable, which means they now guarantee backwards compatibility. Some of the graduated construct libraries that I want to highlight are Amazon EKS for Kubernetes, Amazon CloudFront, which is one of the most popular construct libraries, Amazon OpenSearch, the successor to the Amazon Elasticsearch service, AWS AppMesh for service discovery and containerized applications, and Amazon CodeGuru for AI-powered insights into your code base, and finally, Amazon DocumentDB, the MongoDB-compatible managed NoSQL document database. So what's next for CDK in the area of major improvements and coverage? One of the main focuses of the team will be graduating Go support to stable. Like Jas mentioned before, we launched support for CDK and Go this year, but that support is still considered developer preview. We want to graduate it to generally available next year, so if you're a Go programmer, we would love to hear feedback from you on how your experience is writing CDK code in Go. I want to emphasize that CDK v2 being generally available does not mean that version 1 is abandoned. We will announce soon a detailed plan with the exact timeline of how long and on what level of SLA will v1 be supported, but as of this moment, both versions of CDK are supported. Having said that, we anticipate that the CDK ecosystem will grow around v2 because of the improved third-party library support that we talked about earlier. And for that reason, we would urge you to migrate to v2 if you can. Like I said before, we tried making the migration process as straightforward as possible. As for layer 2 coverage, we want to graduate as many libraries from experimental or developer preview as we can. Some of the ones I want to highlight are AWS App Runner for high-level concepts around containerized application, Amazon Kinesis Data Firehose for data streaming, AWS Service Catalog, including the ability to define products completely in CDK code, and AWS IoT Core, which opens up the entire huge Internet of Things space to CDK customers. And finally, I want to highlight the involvement of the CDK community in creating and graduating these construct libraries. There is no way the CDK team would have been able to improve the layer 2 coverage so much without the participation from our amazing community. So I want to use this opportunity to say thank you to everyone who contributed to the CDK. Up to the beginning of November 2021, we've already had 563 external contributors to the CDK this year, a number I honestly think is quite astounding. That's up from 510 contributors in total in 2020. So we've already grown significantly, and the year is not even done yet. We recognize how lucky we are to have such an amazing community around the CDK, and Next year, we want to double down on it. We hired a dedicated community manager, and we want to invest heavily in this area with things like contributor programs, community events, and other initiatives. So expect exciting news in this space in the near future. When using the CDK, if you discover that our layer support has a bug, is missing some feature, or even support for an entire AWS service, I would really urge you to consider contributing a coverage improvement to the CDK. Don't worry if you've never done it before. It's actually really easy to get started. We have very detailed documentation on our GitHub repository explaining all of the steps of the contribution process. And we even have an in-browser ID with all of the code already built and ready to be modified. So you don't have to set up a development environment on your local machine if you don't want to. So that's layer 2 coverage, but of course layer 1 coverage is provided in the CDK by the CloudFormation resources directly. So Jess, why don't you tell us all of the exciting news from the area of coverage that happened in CloudFormation last year?
Thanks, Adam. Those contribution numbers actually look awesome, so thank you to the CDK community for making this happen. Now for a bit more context and information on CloudFormation's coverage. CloudFormation currently has about 1 million customers. That roughly amounts to about 20 million stacks every week. So I know that's a lot of responsibility, right? Like with great power comes great responsibility. So we take coverage very seriously. We have been making huge strides in making that happen from the get-go, and that's why this year we've actually been able to provide support for 20 new AWS services from day one. And for the existing services, we've been making a lot of improvements in the background, trying to get information from our GitHub coverage roadmap that's actually on GitHub. I see a lot of people like adding issues on there, +1ing issues, so keep that coming. That's really what helps us to prioritize those issues. And a high-level overview of where we stand right now. CloudFormation provides support coverage for about 165 resources out of 174 eligible ones. That roughly amounts to 823 resources out of those 165 services. Okay, so I do want to start a small discussion here. How many of you have heard recently about our service limit increases? Awesome. Well, I know we did a lot of those service limit increases in 2020. That's really so we can reduce some of the friction you have in your development cycles, because you have to keep raising support tickets to have that go through and then wait for that response, right? So we hear you. We did raise 5 of them last year, including the number of resources per stack to 500. This year, we actually raised the service limit for the number of stacks per account. It's actually gone up from 200 to 2,000, the default number. So that's actually good stuff for you. Now you don't have to raise service limits every time you create an account, right? And this used to be very much of a default behavior in the past. In terms of major launches for CloudFormation, you might have already heard this from Werner's keynote or read the blogs that came out a few months back. Cloud Control API was a way in which we really want to eliminate the need for you to write and maintain and set up custom code for each and every single AWS service out there. Right? So with this new set of APIs, all you need to do is use a predefined set of CRUDL APIs. So by CRUDL, I mean create, read, update, delete, and list APIs. And for example, in the slide I have here for list resources for EKS cluster, right? That, the first part, AWS Cloud Control list resources, -- type name, that's the same for any AWS resource out there. Right, so you can see the power of this. Now you no longer have to go and find what's the right one for each and every single service. Much like the coverage update I gave earlier, CloudFormation's AWS Cloud Control API is always up to date with the latest resources as well, because it's actually built on top of CloudFormation's registry. So if you're a partner or an ISV, I would suggest that you integrate with Cloud Control API like literally once, and after that, all the new features and services, you just get that support from day one. And we are going to really strive, like I mentioned before, to make that coverage push next year. So time equals money, right? In the next section, Adam is actually going to kick us off with how you can save more time using reusable infrastructure patterns.
Thanks, Jess. So in this area, we'll talk about how to discover, share, and consume reusable infrastructure patterns so that you don't have to reinvent the wheel, and so that you can share common solutions either within your company or with the entire community if you want to make your pattern open source. Like Jess already mentioned, CDK is all about building reusable infrastructure abstractions, and the way we express that in the CDK is by using constructs. Now, since constructs are represented by classes and objects in the programming language they are written in, the most natural way to share them as patterns is to publish them as native language packages. So a TypeScript or JavaScript construct library would be published as a package to npmjs.com. A Java construct library would be published as a jar file to Maven Central, and so on and so forth. This makes consuming construct libraries extremely natural from their respective languages, and frankly, that's what developers in those languages expect, and rightfully so. But that solution has a downside, and that's discoverability. Since these construct libraries are vended through each language's package manager, they get lost in the sea of thousands or millions of other packages that are also vended through that same channel, and that means discovering construct libraries can be a challenge. And because of that, I'm very excited to announce that Construct Hub, our solution to this problem, is now generally available. Construct Hub is a publicly available catalog of open source construct libraries, at the time of this talk containing more than 700 of them. It's a website available at the URL constructs.dev that allows you to browse, search, and explore construct libraries in all languages CDK is available in. It supports construct libraries for all CDK variants, so AWS CDK, of course, but also CDK and CDK for Terraform. The way it works under the hood is that the Construct Hub backend indexes TypeScript construct libraries published to npmjs.com. That's because JSII, the technology behind CDK's multi-language support, requires that all multi-language libraries be written in TypeScript, and then the code for the other languages is generated at build time. Construct Hub uses metadata produced by JSII to establish what languages your library supports, and this means you don't have to register your library with Construct Hub for it to show up there. Simply publishing it to each of the language's package managers is enough for Construct Hub to discover and index them. You can search the libraries on Construct Hub using full text search, and once you find a library that you are interested in, you can explore it in any language it supports. And the page will give you a ready-made declaration that you can copy and paste to your build tool to take a dependency on the library. And as you switch the same library between languages, you will notice that the README file that explains how to use it has its sample code translated to the correct language, even though the library author only wrote example code in that file in TypeScript. Additionally, Construct Hub will generate an API reference in the selected language, detailing every class, method, and property the public API of the library consists of, alongside the inline documentation for each of those elements, and that any sample code inside that inline documentation will also be translated to the selected language. So what's next for Construct Hub now that it's GA? Well, those eagle-eyed among you might have noticed that the slide is missing Go from the list of translated languages. That's not a mistake in the slides. Go is not actually translated today, and adding support for it will be the team's main focus in the near future. And they're also exploring allowing deploying a company private instance of Construct Hub in case you want to make your company patterns more discoverable, but you don't necessarily want to make them public. So that's how CDK allows you to publish and consume reusable infrastructure patterns. Jess, why don't you tell us how to do that in CloudFormation?
Thanks. Okay, so thanks so much, Adam. We learned so much about how we can use reusable contact with CDK. So CloudFormation's equivalent is CloudFormation Registry. CloudFormation Registry was actually released in 2019, and it uses a concept of extensions. For those of you that are already familiar with it, there's obviously the same concept even for the third-party registry, but for those of you that are not, let me just quickly explain the concept of extensions. Think of extensions as a reusable artifact that you can register and then activate. Right, so be it modules or resources, it's a very good way for you to reduce the amount of time that you're going to use in your development cycles. Earlier this year, I think it was in mid of this year, we actually released CloudFormation's third-party registry, which is nothing but the inclusion of third-party resources into CloudFormation's registry. So there's a few benefits that really stand out for customers that use registry. The first one, you can continue to use AWS config to manage compliance, right? So if you would like to track the different changes to your resources, you can do it the same way that you did with just regular AWS resources. You can also use config to write config rules and then make that the way to assert best practices in your organizations. Another good reason, and this is a personal favorite of mine, it's going to allow you to use a lot of those managed service capabilities of CloudFormation. So be it the drift detection or resource import, using resources from CloudFormation registry automatically gives you that benefit. So I would like to show you this with a bit of a demo so you all can see how this actually works. So give me a second to set it up. Okay.
You're on.
I'm on? Oh, good. Perfect. Okay, so I am right now in the CloudFormation console page. Let me go ahead to registry. So in registry, this third-party publisher, that's the new one that we've just introduced. There's about 45 of them right now. There's more coming next year, so you'll have more options to play with. For the purposes of this demo, I would like to use the EKS cluster resource that has been created by the AWS Quick Start team. So I'm going to go ahead and click on that. There's a bit more information about the resource itself. Feel free to skim through the schema. And then obviously there's documentation that this would actually take you to the GitHub page of this resource, and there's ways in which you can use it as well. Okay, so I'm going to go ahead and activate it. As you can see, it asks for some simple steps. I've already created an execution role ARN because I created a stack in preparation for this demo. So I'm just going to paste that IAM role here. And I'm keeping the default, keep the versioning on. It's usually better for you that way. And I will go ahead and activate extension. That's it. It's as simple as that. Now that your extension is activated, you can actually use this in a CloudFormation template. So, all right. So before we jump to the template that I actually created for this right here, these are all the various permissions that you needed to give for this role to be able to actually execute upon this resource. So this is the CloudFormation template that I've created. As you can see, I'm using the AWS QS EKS cluster resource. Just so you know, if you forgot to do the first step of activating the resource and you try to run this template using this resource, you're going to get an error. So it won't allow you because you have to activate it in the registry. I've hard-coded some values in here, and the cluster is going to be called my cluster. Let me go ahead and start this stack. There it is. So stack has started to be created here. Let me switch out. Okay. Going to stacks. Let's just go to in progress. Okay, so this is the stack that just got created. So this is going to create our cluster. So as you can see, the service role has been created, and my cluster is in progress. So this is where it's going to take about 20 minutes. We don't have that much time for the demo. So I don't want you guys to miss out on the fun. So I'm going to just show you a video of like at least the events, so you'll get to see what that feels like, when that thing actually completes. Sorry. Okay. All right, so as you can see, this is the same template that I just showed you, and I ran the same command. So this is where we left off, and I'm just going to show you this video that will actually complete. Right, so my cluster, create complete, EKS cluster has also, the stack has also been completed. Let's move on to the EKS console. And this was the cluster that was actually created. And as you can see, it's actually active right now. Just note that cluster name, because that's the one that's going to be used in my next phase of my demo as well. All right. So let's go back to the second phase of this demo. So now that we've actually created an EKS cluster using a third-party resource, I want to deploy a workload into that cluster. And I'm going to choose a Redis cluster to be deployed in it. I'm going to go with a construct from the construct hub that Adam very nicely introduced to us. And I'll just show you what that looks like. So here's construct hub. I hope a lot of you here are familiar with this. Like I mentioned, I would like to deploy a Redis cluster. So there's a few options. I'm just going to pick the first one. I personally prefer Python, so I'm going to switch to Python. One of the first things you might want to do if you want to use a construct is make sure that you actually run this. This would make sure it adds the required dependencies. And I can just show you that. So I already ran this command, the one that I just showed you, the pip install command, and it just added this dependency for me. And that's in the setup file. So moving on to the next portion. After you actually add your dependencies, make sure you're importing the right libraries, right? So this is just a CDK app, very simple one. Once you import the libraries, CDK, as well as a CDK Redis library, just to give you a one-liner of what CDKs are, it actually allows you to define a Kubernetes resource for CDK. So that's what CDKs are all about. And then the second section of this file, of this app, as you can see, is it's actually importing the cluster. I previously shared the cluster name to you guys as well. And you can see that that's the same cluster that I've imported here. VPC is the same thing that the cluster was previously deployed in. Obviously needed to define an IAM role that would allow me to access these clusters using kubectl. And then when I initially ran this, I ran into an error, obviously, right? Like I didn't have any compute instances in there. So I could have done one of two things, right? I could have added this as part of my previous CloudFormation template as well. But for this demo, I'm just going to add, I actually used a CDK to add a node group. So now that we have some compute power, we can go ahead and deploy our Redis cluster. And I just want to show you in here. See, this is the same thing that I've actually used here, right? And then you deploy it into the cluster that we already imported. So now that that's done, all you're going to do is deploy your CDK app. And this was going to take 7 minutes. Don't have that much time right now, so I'm just going to show you another video of how this happens like in a fast-forward way. Okay. All right, so as you can see, this is the same file. Cluster, I've already hit CDK deploy. Takes a bit. It's starting to create the node group role. The role has been created, and now it's going to create the node group itself. And now it's actually created the Redis cluster as well. We're just going to go and check this in the EKS console. So node group getting created there. We can just go quickly check in our stack events to see if it's completed. Yep, now it's just completed. And it's active. All right, so that's what that looks like, and I just wanted to quickly show you folks that right? So this is the same cluster that I'm pointing to right now. And you can see the cluster. And one last point here before we wrap up the demo. As you can see, it clearly states that using this construct is actually going to define a cluster with a primary and 2 replicas. And that's exactly what we have here. Okay, so that pretty much wraps up our demo portion for registry and construct hub. I think it just didn't switch. Mm-hmm. No, it just goes to the next one. Perfect, okay. I really hope that demo gave you an idea of how you can actually use resources from CloudFormation's registry, as well as you can use a construct from Construct Hub. Well, let's move on to another exciting topic, compliance. And I'll show you how, with some of these features, you can actually step up your compliance game and also help speed up your development cycles. Well, CloudFormation Guard 2.0. How many of you are using this right now in your CI/CD pipelines? Thank you. Not very many, so this is a good opportunity for me to introduce this to you. CloudFormation Guard, simply put, it's an open source, general purpose policy as code evaluation tool. So earlier this year, we actually revamped CloudFormation Guard from 1.0 to 2.0. And the reason we actually did this to actually make this more general purpose. Now, what do I mean by general purpose? Previously, we could only do this against run rules, run your CloudFormation template against the rules. This time around, we're going to be able to do CloudFormation template, Kubernetes configuration files, Terraform state files, all against the rules, which are written in JSON, right? In this slide, I've actually shown you a CloudFormation template written by a developer, such as you folks, named Jack. And when I run that, say, if I run that template against that rules, it's absolutely going to fail on several counts, right? You can already see it, what he's allowed to do versus what he's actually doing. It's going to fail on availability zones, encryption, as well as the size. By plugging in CloudFormation Guard into his CI/CD pipeline, Jack would actually be happy that his resources were not provisioned in the first place, right? Because this would prevent his account from being flagged by the very awesome audit folks that would actually come after him if he had provision this in the first place. And in the audit folks, obviously, they don't want to be running after people either. So I think this is pretty much a win-win on both counts, right? Let me also walk you through another very, very personal favorite of mine, just veering off the topic from compliance a bit, the disabled rollback parameter. If you've not heard about it, this went viral when it hit the street. So if you've not heard about it, I'm here to introduce you to it right now. Let's take the example of let's just say a stack with 10 resources, right? And you are waiting for this stack to complete its deployment. It finishes, first one gets done, second one, and then you're like, the ninth one gets done, and you're like, okay, the last resource, I really hope this gets done, and it doesn't. So what do you have to do now? You just have to wait until all the 10 resources roll back to its last known stable state. And that's a lot of time. And I'm only talking about 10 resources, right? So imagine you having to just use a parameter in your create stack workflow, update stack, as well as execute chain set workflows. All you have to do is add a parameter, disable rollback, as highlighted there, and it would actually allow you to start from the point of failure. Now, what do I mean by that? The 9 resources that successfully deployed will remain as is, right? And the 10th resource, all you have to do is go investigate, find whatever was the problem, and then come back, update your template, and then kick off the deployment, right? And then that's it. It'll be done in just a few minutes, potentially, depending on the type of resource, unless you use a Kubernetes cluster, which is going to take a while. But the point being, this is going to save you a lot of time, right? And it'll just multiply the number of workloads you have. So absolutely use this in your development workflows. I really think this should become the norm in which developers start in programming and developing things in your development accounts. Just so you know, this is not only available in the CLI, it is also available in the console if you want to try and test it out. You can actually find an option for this in the stack failure options section. And you need to, the default is roll back all resources, so you need to move away from the default and select the other radio button, which reads preserve successfully provisioned resources. Okay? I really hope you guys use this and save some time. And speaking of deployments and saving time, I really think I wouldn't be doing justice if I wasn't talking about StackSets. StackSets is CloudFormation's way of deploying stacks across multiple accounts and across regions, right? This year, StackSets team has been releasing a whole bunch of incremental features for you guys. And this is really because we've been listening to customer feedback on the importance of these features. StackSets now will allow you to run non-conflicting operations concurrently. And the ones that are conflicting will be queued up, obviously. You can also deploy a StackSet now across several regions in parallel, right? So now you no longer have to wait for that one region and then the next one, right? These two alone, I promise you, I've heard from developers already, it's going to save a lot of time. Customers have been asking us about a more seamless way of importing a stack into a StackSet, because I know a lot of times developers just start by creating a stack and playing with it, and then they now want to go cross-account, cross-region. They need to make it a StackSet. Now there's a bit more of a seamless way in which you can import that. Customers have also asked us, hey, give us a mechanism by which a member account can deploy StackSet in specific OUs, so that the admin alone is not like a bottleneck, right? So he doesn't have to be the only one doing those deployments. All of these deployments are really preceded by some intensive testing. So Adam is going to walk you through a new CDK feature that will get you through your coding and your testing phase a lot faster.
Thanks, Jess. Yeah, those are all great features. I know disable rollback especially is very popular among CDK customers, and we'll see how to use it from the CDK during our second demo in just a minute. The first major launch in the area of compliance testing and deployment automation that I want to cover today is the CDK assertions library. Now, one of the advantages of using a programming language to model your infrastructure is that you can write your unit tests for your infrastructure code same way as you can write unit tests for your application code. However, the feedback we got from CDK customers is that it's actually pretty difficult to write unit tests for CDK code for two separate reasons. One, CDK code produces CloudFormation templates as a side effect of executing it, and it's tricky to get access to those templates without writing some boilerplate code. And two, formulating assertions on those templates is actually not very easy or readable because the generic unit testing tools for each language have no way of taking advantage of the fact that these files are valid CloudFormation templates and thus have a very specific structure. Because of that, I'm very excited that our solution to these problems, the CDK assertions library, is now generally available. The CDK assertions library is a collection of helpers and utilities available in all CDK supported languages that allows you to easily and concisely write unit tests for your infrastructure code. As an illustration, let's look at the example shown on the slide. It's using Python, but very similar code would work in other programming languages. We have our production code, in this case the MyStack class, that contains a single resource and S3 bucket with a particular name. We then use the unit test Python module to write a simple unit test that instantiates the MyStack class and asserts that the resulting template contains an AWS S3 bucket resource with the correctly filled bucket name property. The assertion library contains many more utilities besides the ones shown here. It allows you to count how many resources of a given type are in the template, do partial matching on objects and arrays, assert the absence of a property in the template, and many more. In addition, it supports snapshot testing, where you save the entire output of the CDK code inside of your test, and then whenever that output changes compared to the stored snapshot, the test will fail. And that allows you to make sure that things like dependency upgrades or refactorings of your CDK code have no unforeseen side effects on your CDK application. The second major CDK launch in the area of compliance testing and deployment automation this year is graduating the CDK pipelines library to generally available. CDK pipelines is a construct library that allows you to model a CI/CD pipeline for your CDK application using CDK code. It supports CDK application of any complexity, consisting of arbitrary many stages, each stage potentially having arbitrary many stacks inside of it. It has built-in support for cross-region and cross-account deployments. As we can see here on the example in the slide, I don't want to focus too much on the details of what this code exactly does. The CDK pipelines library has excellent documentation explaining all of it, but I just want to emphasize how relatively little code is needed to build a fully functional cross-region and cross-account pipeline that will not only handle all aspects of deploying your application, like handling assets and making sure the stacks are deployed in the correct dependency order as expressed in your CDK code, but that is also self-mutating. Meaning, if you want to make a change to your application structure, for example, you might want to add a pre-production stage in front of your production stage. You make that change in your CDK code, you push it to your source repository, and then the pipeline will pick it up, self-modify itself to insert the new stage in front of the existing stage, and finally deploy your application to the new stage, all without any manual intervention from your side. This way, you don't have to rely on anyone manually running CDK deploy from their machine in order to update your application. All changes can go through source control, which means you can do things like gate changes with code reviews, rollback changes by reverting commits, and apply all of the other well-known good practices associated with continuous deployment. CDK pipeline ships with support for AWS Code Pipeline as the backing engine for your deployment pipeline, but the pluggable backend delivered as part of the GA release actually means there might be other backend implementations in the future, for example, using GitHub Actions or Bitbucket pipelines. And finally, the last major CDK release in this area that I want to cover today is the new CDK watch command. You might be familiar with watch commands from other tools like the TypeScript compiler or the Jest testing framework, and the CDK equivalent follows the same basic principle. It's a continuous process that you start from the command line, and the slide shows an example session using the command. After it starts, watch observes the files of your project, and whenever it detects that one of them changed, it automatically triggers a CDK deploy of the selected stack or stacks, and it doesn't need you explicitly invoking any command to do that. And the purpose of this is to shorten the change, deploy, test, feedback loop as much as possible when you're quickly iterating on the code of your CDK application. And because of that, Watch by default uses the new hot swap deployments. This is another capability added recently to the CDK, and it allows, under certain conditions, CDK to perform a much faster deployment than usual. For example, when only the code of a Lambda function in your application changed, but you changed nothing else in your CDK code, a hot swap deployment will update the function directly with the new code. And that has a pretty dramatic effect on the deployment speed. As you can see from the slide, we went from minutes to seconds. So what's next for CDK in this area of compliance testing and deployment automation? Well, for CDK Watch, our main focus will be hot swap deployments. As of this talk, the supported resource types for hot swapping are Lambda function code changes, step function state machine definitions, and ECS service image changes. We want to expand this set to more resource types. For example, static websites hosted in S3. We also want to support hot swapping of resources in nested stacks, not only in top-level stacks. And finally, you want to make the architecture that enables hot swapping more of a plugin architecture, which will allow CDK customers to add support for hot swapping any resource they want and distributing that support as a library, without having to wait for the CDK team to implement it. For compliance, we're looking for adding more enterprise-grade features in this area. One possible integration we are exploring is with the CFN Guard tool that Jas mentioned before. Of course, you can run CFN Guard on CDK-generated templates today, but we want to streamline this experience so that you don't have to manage the two tools separately, but they work together seamlessly. We are also looking into making CDK easier to use in enterprise environments that are more restricted. For example, in situations where only a central team has permissions to manage IAM resources. And finally, for testing, we want to expand our current support for unit and snapshot tests with integration tests, meaning actually deploying your CDK stack or stacks and running assertions on the provisioned resources, making sure that the correct IAM permissions are in place, that the security group rules allow connectivity between the components that need it, and other similar assertions that really can only be verified by running them against real resources in the cloud. So let me show you a quick demo of using CDK Watch, the new desirable rollback parameter in CloudFormation, and the assertions library. So I have here a CDK application. It's written in Java, and I've already deployed it. It consists of one stack, and inside of it, we have a step function state machine. Right now, it's extremely simple. It just has one succeed task as its definition. So I can invoke the CDK command. So I will invoke the watch command with the -r, capital R parameter, and that will tell CDK to pass the disable rollback parameter to CloudFormation when performing deployments. So if I now uncomment this code, this adds a new SNS topic to my application and a new, using the standard level 2, layer 2 CDK construct, and then SQSQ using the layer 1 construct. So if I save this file, you can see that watch picks it up and detects those changes, and it triggers a deployment for me. Now, the interesting part about this change is that I told the queue to reuse the built-in KMS alias for SQS, but I told it to reuse it for 30 seconds, which is actually wrong because the minimum period you can give to SQS for using the key is actually 60 seconds, which means this deployment will fail, and we can see it here. And what would happen traditionally in CloudFormation without the -r option is that the topic, even though it's created fine, would be rolled back at that point. But if we go to the CloudFormation, the AWS console for SNS, I can see that the topic was actually not rolled back. So even though the deployment failed, the topic was created, and that means I can actually use it in my CDK application. So for example, I want to add a step functions task that publishes a message to this new SNS topic that I created. I just post a very simple text message. So I change this part, and again, I save it and let CDK watch pick up the change. And what we should see, you can see how quickly that deployment succeeded. So after the application was synthesized, it literally took a second or two for the deployment to finish. And the reason is that CDK noticed that the change is only to a definition of the state machine. So it didn't have to do a full deployment. It just updated the definition directly in the definition of the resource. So now if I go to the step functions, AWS console, and I go to the definition of the state machine, we can see the update has been done. It has two tasks as part of it. And finally, the CDK assertions library. This is an example of a unit test written using JUnit that instantiates my production stack and then asserts that it contains a specific a state machine with specific properties, the role arn that exists in my account, and the definition string, and I can run it directly from my IDE, and we can see it passing. Yeah, so that is the CDK watch command, the disable rollback parameter in CloudFormation, and the CDK assertions library.
Thanks, Adam. I think we need to switch, right? Perfect. It was actually great to see a lot of concepts being pulled into one demo. But we need to jump into the last leg of our session. I do want to kind of sum it up and have everybody take away a few key things, right? The first thing that I mentioned at the beginning of the session, CloudFormation and CDK, these are really like two sides of the same coin, very complementary. It's really up to you to choose what's best for you and what's your preference. And I want you to know that there's a lot of investments being made in terms of CloudFormation coverage for next year. And we would really love it if you could help us prioritize by adding your +1s or creating new issues in GitHub coverage roadmap. And we will follow up with the respective service teams to make sure that the CloudFormation support is created correctly. And absolutely try and migrate to CDK v2. We would really love your feedback. I know that compliance is kind of key in a lot of these deployment cycles these days, so feel free to use Guard in your CI/CD pipelines. Use CDK assertions to try and accelerate your testing cycles. Adam showed us a demo of that as well. And absolutely try and use a construct from Construct Hub. There's over 700 of them. I'm sure there's something for everyone there. And I just want to give you guys a little bit more of a resource. Feel free to look at these sessions. Some of them have already been completed because it is Thursday at reInvent. But feel free to look them up. They are available on demand. And another good slide for you folks that are very interested in diving deep into some of the concepts and features that we introduced. I'm just going to pause a bit because I see a lot of cameras out. Can you go back to the previous one? Okay. Let's move on. Pause a bit here as well. All right. Well, with that, thank you so much for attending our session. I hope you're really excited to try some of these features, and we would love your feedback.